This is for Year 12 methods. It's to support how to use the calculator to do the functions revision for 2014. Okay, this is the tech allowed part of the Kilbaha 2014 trial. At a circus, roller skaters move up and down this ramp. The ramp's designed as a function of x. The horizontal distance from the origin and y represents the height of the ramp. The ramp has a width of 3 meters and a height of d. Point A is located horizontally at the midpoint of the ramp and is 3.75 meters above the ground. So this is point A, which has to be at 3.2 because it's halfway, and 3/8 because that's what 0.75 is in standard form. And there's three conditions. The origin has to have a gradient of 0, therefore f dash of 0 equals 0. The point A of the tangent has a ramp inclined at 45 degrees. Since the tan of 45 degrees equals 1, therefore the gradient is 1. And the gradient of the ramp is always increasing. It's always got a positive gradient. So we're going to have f of x, g of x, and h of x to model this ramp. If f of x is ax squared, show that this function satisfies criteria 1. Criteria 1 is that at 0 the gradient is 0. So take the derivative, I get 2ax, that's 0, that's true, and it's show that it's not possible for criteria 2. Well, we need to know what a is. So f of 2 equals 3/8, solve that for a and you get a equals 1/6. Take the derivative and we don't get 1, we get a half, therefore it's not true for criteria 2. Part B, g of x is bx cubed plus cx squared, where c and b are constants. Okay, so on my calculator, I'm going to I've got b x cubed plus c x squared. And the first condition is that g of 3 of 2 is equal to 3/8. So equals 3 divided by 8, given x equals 3 on 2. And that gives me my first equation in terms of b and c. The second equation is that if I take the derivative with respect, take the derivative with respect to x, and that's going to equal 1 when x equals 3 on 2. And that gives me my second condition. And if I open up simultaneous equations, put that there, and solve it for b comma c, I get b equals 2/9 and c equals negative 1/6. Explain why the function does not satisfy criteria 3. Criteria 3 is that the gradient is always positive. So if I go back over here and I take this, copy, paste, given b equals this, and also given c equals this, this is my expression. If I take this and I take its derivative with respect to x, and I set it equal to 0, and I solve it. So I'm solving the derivative equals to 0, and that tells me that it's equal to 0 at 0.5. So in my domain, then I'm going to have, which goes up to 3, I'm going to have a turning point. So therefore, when x equals a half, the gradient is 0. Criteria 3 says it always has to be increasing. Now, in actual fact, if I look at this function, I can see that between 0 and a half, it actually has a negative gradient. So, g dash of x is negative for 0 to a half, therefore not positive gradients fully as expected in criteria 3. Part C, again, I've got h of x equals x to the n over k. Show that k equals 27 on 2 and find the value of n. I'm going to do a similar thing, but this time I'm going to use simultaneous equations. So I know that h of 3 on 2 equals 3/8. So I've got 3 divided by 8 equals, and it's x to the power of n over k. And that is when x equals 3 on 2. And that gives me equation number 1, and there it is there. And I know the derivative, so if I take this and I take its derivative with respect to x, and I make that equal to 1 when x equals 3 on 2, that gives me that expression. And I've got that one, so I can open up simultaneous equations. Take that, put that there, take that one, put that there, and I solve it for n and k. And I'm told that k equals 13.5, which is 27 on 2, and n equals 4. For this function, find the value of d. D is the height at h of 3, so d is h at 3, and that's substituting 3 in, and I get 6. The function has an angle of inclination in degrees and minutes, the tangent at the highest point of the ramp. Tangent at the highest point of the ramp will be when x equals 3, and it will be h dash of 3. So I know that this is my expression, and if I copy that, move that down, and I paste, and I know that that's 4, and I know that k equals 13.5. That gives me my expression, and I wish to take its derivative with respect to x at x equals 3. So math 3 given x equals 3, and that gives me 8. So the gradient is equal to 8, therefore the angle will be the inverse tangent of 8, making sure that I'm in degrees and in decimal. And if I 2 degrees minutes seconds of this, I get an answer which is 82 degrees 52 minutes 29 is just shy short of 30, and 30 would be how many? Would be halfway, so 82.52. And find the function, the cross-sectional area of the ramp is going to equal the definite integral, from 0 to 3 of this respect to x gives an answer of 3.6, or in standard form, an answer of 18 on 5. That's the first question.